Selecting features is one of the core functions of a GIS. Often, you may only be interested in a subset of a data layer. When you select spatial features, the corresponding records in the attribute table are also selected, and vice versa. Any GIS operation can be run on just the selected set of records or features. For example, if you have counties of the US and you select those in Vermont, you can save the selected Vermont features or records as a new GIS layer. Any GIS operation can be run on just the selected set. Selections can be done interactively, using expressions to query the attributes of a layer, or spatially. Here you'll be introduced to all three methods. Here I have QGIS Desktop open with the QGIS map document from Lab 4 Task 2. I've just disabled the fast food heat map and the fast food restaurant locations. First, let's explore interactive selection. I'll select the neighborhood diabetes layer in the Layers panel. Then I'll click the Select Features by Area button. There's a drop-down tool menu that provides several ways to select features interactively. I'll choose Select Features and click on a feature on the map, and it'll be highlighted in yellow. Now I'll open the attribute table for this layer. There's one selected record, so the corresponding record's also selected in the attribute table. Whenever you have a selected set of records, you can use the Show All Features drop-down menu in the lower left corner to show only the selected records. There are several other options available on this menu. I'll click Show Selected Features, and now I see just the selected record. Now I'll close the attribute table. This Select Features tool can also be used to select multiple features. Using the tool, I'll left-click and drag a box with my mouse button across a portion of the city. All the polygons I interacted with will become selected. To unselect these features, I can click the Deselect Records button. Now I'll explore attribute queries, using the Select by Expression tool to select neighborhoods with high poverty rates. I'll open the Neighborhood Diabetes attribute table again. In addition to the diabetes data I joined to this table, there's a lot of other columns of socioeconomic data. I'll click the Select Features using an Expression button to open the Select by Expression window. On the left is the window where I'll form my SQL expression. In the middle are the available functions. On the right is a context window that provides help and sample field values. And across the top are some commonly used operators. I'll expand the Fields and Values section, and the attribute columns in this layer will be listed. I'll select the Poverty column. The right window splits into Help and Values. I'll click All Unique, and QGIS will scan the column and print all the unique values in the Poverty column for this layer. These represent the poverty rates. I'll double-click on Poverty to add it to the expression area. Then I'll expand the Operators section. I'll double-click on the greater than operator to add it to the expression area. I'll scroll back down to the Fields and Values section and again select Poverty and click All Unique. To complete my expression, I can either use one of these values by double-clicking on it, or I can type a numeric value into the expression. I'll double-click on 20 to complete my expression. Poverty greater than 20. With my expression complete, I'll click the Select button. "117 neighborhoods match my query. They're both selected on the map and in the table. I'll close the Select by Expression window. I can click Unselect All to clear my selected set of records and close the attribute table. Another useful technique is feature selection by location. This allows you to select features in one layer that intersect or touch features in another layer. I'll use the Select by Location tool to identify neighborhoods with a fast food restaurant. I'll click on the Vector menu, go down to Research Tools, and choose Select by Location. For Select Features In, I'll choose Neighborhood Diabetes. For that intersect features in, I'll choose Baltimore Fast Food. And I'll make sure Include Input Features that intersect the selection features is checked. At the bottom, there's a drop-down that lets you choose what kind of selection you'd like to make. I'm going to use Create New Selection. However, note that there's also the option of adding to current selection or removing from current selection. I'll click OK and close. The neighborhood polygons that intersect a fast food restaurant point are now selected in yellow. And I'll turn on the fast food restaurant location so you can see that relationship. Now I'll open the attribute table for neighborhood diabetes. There are 271 records in the table, meaning there are 271 neighborhoods in Baltimore City. Of those, 85 are now selected, meaning they have a fast food restaurant. I'll scroll to the right side of the table where the Baltimore City D column is. This is the column that contains the number of people diagnosed with diabetes. Remember, I joined this column to the neighborhoods layer in Lab 3 Task 2. I'll click the column header to sort the table based on these diabetes values. I'll scroll up and down and observe the values. Notice that the majority of neighborhoods with high diabetes are selected. I'll close the table. Now I'll explore these data a bit more. I'll click the Vector menu, Analysis Tools, and choose Basic Statistics. This will give me an interface for calculating basic statistics on numeric attributes. I'll set the input vector layer to neighborhood diabetes. And check Use Only Selected Features. I'll then set the target field to Baltimore City_D, the field that has the diabetes data in it. And I'll click OK. Basic statistics on the number of diabetics in the selected neighborhoods are now displayed in the main window. This shows that there's 40,433 diabetics living in these neighborhoods with easy access to fast food. I'll repeat this, but now uncheck Use Only Selected Features. Click OK. This shows that there are a total of 82,831 diabetics living in Baltimore City. You now know that of those, almost 50% are within neighborhoods with easy fast food access. I'll close the Basic Statistics window. In the next task, you'll learn how to calculate areas and density.